Okay, good morning, everybody. So today, this is going to be a pretty brief video. I just want to go over some more matricy or matrix properties with you. Actually, I don't think we've gone over, so I guess this would be the first time, not some more, but some matrix properties with you. Okay, good morning, everybody. I hope you're doing well today. So the today's going to be a rather short video. I just want to go over some matrix properties with you. These are pretty simple, but they do need to be mentioned because as we move forward with various matrix operations, it's important that you know what you can and can't do. So let's look at the first one. You can see right here that you have A and then B and C is grouped together, and in the second one, A and B are grouped together and C is not in the group. One thing to note is the order did not change of the matrices. That's very important. This, if you don't recall what this property is called the associative property. And for multiplication, just numbers, when we multiply numbers, that property holds true. It doesn't matter what order we multiply them in. We can switch them, which would be the commutative property, or we can just group them together. Doesn't matter. It also does not matter with matrices as long as the order of the matrices does not change. Because if you look down through here, you can see we have the associative, we have distributive, and then we have another associative property. What we don't have is the commutative property of matrix multiplication. Matrix multiplication, you cannot switch the matrices. And that has to do with what I showed you in the previous video, where the orders have to be correct. Those two center numbers need to be the same. So you can't switch orders of matrices, but you can group them differently as long as the matrices stay in the same order. The next one is the distributive property of matrices. And you can see this matrix right here, A, you can take that and distribute to the B and the C. The one thing to keep in mind is that this A was originally to the left of B and C. And if you look over here, A is still to the left of B and C. And that comes back to where I said that there is no commutative property of matrix multiplication. So the matrices have to maintain their order in order to multiply them, even with the distributive property. This just shows you with the C right here. You can see the C is to the right of A and B. So when they distribute it, the C remains to the right of A and B, maintaining the order of the matrices so we can multiply them. The last property is the associative property of scalar multiplication. This C right here represents a scalar. A scalar is just a simple number like 5, right? So if you have that C can multiply A first, and then you can do the matrix multiplication A times B. Or the C can multiply the B first, and then you can do the matrix multiplication. So, and as we work through different example problems, this will make sense to you. One other thing, in matrix multiplication, the identity matrix is the matrice that has a 1 on the diagonal and zeros everywhere else. For addition, the identity matrix for addition is all zeros. But for multiplication, the identity matrix is all ones on the diagonal and zeros everywhere else. And what this is showing you is an example of why this matrix right here with all ones on the diagonal is considered the identity. Because when I took that and I multiplied it by this matrix, I got the same answer as what I started with. The same thing over here. I took the identity matrix, I multiplied it by this, and I got the same answer. So it's called the identity matrix because it is maintaining the original identity of the matrix we multiplied. All right, told you it was a quick one today, so hopefully that made sense. If you have any questions, email me. Have a great day.